One of the universe's greatest mysteries may be hidden within black holes, some of its most fascinating objects. Why are we in a habitable universe? How is it that we can be alive today? If even one of the fundamental constants of nature were slightly different, life as we know it could not exist in this universe. And neither you nor I would be here to witness this strangeness. Let's take a few concrete examples. You'll see, it's unsettling. If the rate of expansion of the universe were greater than it is now, matter would have had trouble clumping together. There would have been very few stars or planets, and our universe would be almost devoid of large structures. If the force of gravity were slightly weaker than it is, then the universe could only give birth to gigantic stars. Stars much larger than our Sun, which burning too quickly and intensely would prove to be hellish for the planets orbiting them. On the other hand, if that same force were slightly stronger than it is, there wouldn't have been any stars heavier than our Sun, and carbon, an element essential to life, would be almost absent from the cosmos. Because it's this type of star that mostly produces and distributes it in the same way: ideas. A slightly stronger or weaker electromagnetic force would make stars, as well as complex molecules, highly unstable. Even a slight change in the relative masses of elementary particles would have disastrous effects on life. Consider that if the mass of protons were a little greater than that of neutrons, whereas in our reality, it's the opposite. The only matter existing in the universe would be neutronium, and none of the chemical elements we know today could have formed. If the nuclear force holding atomic nuclei was a bit weaker, most elements would be radioactive, and the nuclear fusion reactions taking place at the core of stars would have been much less energetic, effectively reducing their lifespan. If this nuclear force were even weaker, only hydrogen would exist in the universe. As a result, as soon as they formed, stars would have immediately collapsed into white dwarfs, neutron stars, or black holes. And we could go on like this for a very long time. Each time, it would be enough to change the value of one of the fundamental constants of nature by just a tiny bit to end up with a hostile universe for life as we know it. The big question behind all this is, who gave the fundamental constants of the universe their values? And why do they have, among an almost infinite range of possibilities, these values rather than others? This question is still one of modern physics' biggest mysteries. A deeply religious person might explain this oddity by asking, is there something behind this? A deliberate adjustment? It's God, in any form you choose. Who else would press the buttons? Discussion over. But if that hypothesis, which is a rather common argument, doesn't satisfy you, then you have to keep thinking. You can, for example, consider that something intrinsically built into the universe forces the constants to take these values. Or else consider that if the constants of the universe seem so precisely tuned, allowing life's complexity suggests many other parallel universes exist elsewhere, but they are defective or sterile. For more on this hypothesis, see the Multiverse's video. The thing to remember here is that what we might be tempted to see as a lucky coincidence would, in fact, only be the result of a large number of attempts. Because even if the chances of randomly ending up with a universe suitable for life seem ridiculously small at first, with a very, very large number of universes, it inevitably ends up happening. And if these explanations still don't satisfy you, if you refuse to see it as just a simple lucky coincidence, then you can bring in. Black holes are proposed by the unusual theory of cosmological natural selection, created by physicist Lee Smolin, and according to which our universe would have formed inside a black hole created by a universe from which it would have evolved. Before immediately throwing away this hypothesis, which may seem completely insane, we're going to have to hold on a bit. Don't worry, you'll see, it's fascinating. To understand how black holes could have been creators of universes, we need to look at what happens to everything that has fallen into them. It's believed that all matter, once it enters a black hole, inevitably ends up concentrated at the center, compacting into a tiny volume of space, reaching truly mind-boggling densities. Touching infinity, in this bewildering region, what is called a singularity forms, where gravity and quantum mechanics lose their footing. We observe instabilities in the equations, dimensionless volumes, and infinite space-time curvatures. By doing this, some suggest that the center of black holes isn't meant for matter, space, time, or radiation, despite all the possible implications of these oddities. The end of the story, but the beginning of something else. The conditions that theoretically prevail at the heart of these singularities, with their infinite density and their warped space, are indeed strangely similar to those that existed during the first moments of our universe near the Big Bang. It's possible the center of each black hole causes incoming matter and energy to bounce back. By instantly creating a symmetrical twin, taking the form of a hypothetical white hole, a sort of reverse black hole, a new universe that would begin as a burst of matter and radiation. A great rebound, a Big Bang, creating space and time, and inevitably turning the center of each black hole white. Black holes could be birthplaces. And the moment when time seems to end near their singularity would be the moment when time begins with a Big Bang and creating a new universe. And if you ask why we don't see anything from these bursts of matter and radiation, well, that's because all of this happens entirely wrapped up inside black holes. To understand how it's theoretically possible to fit all the space and room needed for a new universe to expand inside a black hole, consider two things. First, the most massive black holes that Leon knows of can reach impressive sizes and have average densities similar to that of water or even air. On that note, I refer you to an earlier episode where I explained why. It is theoretically possible that our observable universe is contained within a black hole even larger than itself. And then you also have to imagine that a volume that appears as small as that of a black hole can actually turn out to be infinitely large on the inside. To try to give you an image, take a reflective spherical ball, one that reflects everything around it absolutely perfectly. Such a mirror could reflect a distorted miniature image of the entire observable universe around it. Well, let's say in a similar way. The puzzling phenomena occurring near singularities allow a reflection projected from the center onto the inner surface of the sphere to transform on the outside into a new universe. Okay, that was for the part. Black holes could eventually collapse, creating a passage between a dying world and the other being reborn. But that still doesn't explain why our universe has the natural laws and values we observe. And that's where the theory of cosmic natural selection, also known as the theory of fecund universes, really makes sense. Because black holes are places of birth, they help solve the mystery of these values. The hypothesis is that near singularities, during the bounce, the fundamental constants of new universes would shift slightly compared to those of the parent universe. Thus, these new universes born from black holes would not be blank slates. They would not start from scratch. This reasoning grows stronger because, among countless possible mutations, some create universes unsuitable for life. There seems to be some kind of correlation between the values. Constants enabling the formation of many black holes, and as a result, numerous universes. And those that seem to favor the possibility of the emergence of complexity, and therefore of life. In other words, the universe is capable of forming a large number of black holes, and therefore having the greatest number of descendants should also host a greater number of stars, like 2 planets and the exponential growth of the branching process. As a result, the whole set of universes should very quickly be dominated by the most fertile variants. There's nothing remarkable about being in a universe that supports life, since these are actually the most common. And the values of the constants we observe are those that have, in a succession of infinitely nested spacetimes, been somehow selected as they were favored over generations of universes. So, let's be very clear. The hypothesis that our universe was born in a black hole nestled in a larger universe remains, for now, impossible to prove, just like the hypothesis of multiverses or cyclic universes. There are more, but cosmic natural selection, making black holes birthplaces, is one of our few theories. That is able to explain through a logical process the existence of organized complexity. In this view, universes are self-creating without needing anything other than themselves to generate them, give them rules, and make complexity appear within them. One surprising result of this hypothesis, if correct, is as follows. Since our universe hosts life, it's likely it appeared here too, just as in billions of other universes, formed from the black holes that we find in our own universe, universes that are around us. A giant star collapses. A universe forms with every black hole, and when we imagine. It is estimated that there are more than 100 million black holes in our own Milky Way, and that there are dozens to a few thousand light years from Earth. So, if the theory of cosmic natural selection is correct, there would be other universes much closer to us than the Andromeda Galaxy. To explain the origin of the world, many models and ideas abound. This episode is mainly a journey exploring a fascinating proposal worth examining, because it opens new doors, new windows on our way of approaching the problem of the origin of the universe. Obviously, as elegant as the proposal of fertile universes may be, like any other proposal, explanation including God comes first. We will probably never have the final word on the beginning of the story, because nothing will ever answer the question. But what was there in the very beginning before? I hope, in any case, that the idea that our universe could come from a white hole produced by a black hole itself, embedded in an older universe, has crossed your mind with the subtlety of a steamroller of all colors. After this long journey through space, don't forget to check out baladamentalodu.com. I really tried to create something with a clean minimalist aesthetic, all enhanced with my favorite videos. Well, I wonder if, deep down, I'm not a bit inspired by the idea I have of the inside of black holes. Let me know what you think.